Let's try another problem. This vertical side has a length of 3. This horizontal side has a length of 1. Try to figure out this angle and this side. I'll use asterisks to remind myself of the information that I was originally given. And this asterisk doesn't mean that we're given the angle, it just means that we're focusing on this angle. Clearly we're not focusing on this angle down here, we're focusing on this one. This will help us to label that this horizontal side is adjacent to the asterisk, and this vertical side is opposite to the asterisk. And clearly this side is the hypotenuse because it's opposite to the 90-degree angle. This is another problem where we're given two sides. Well, we can find the third side by using the Pythagorean theorem. If you wanted to, you could find the angle first, but usually people find the side first. Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. The hypotenuse is what we don't know. One of the legs is 1, and the other leg is 3. As usual, I recommend first write down the general formula and then plug in when you're first learning the material. Don't just plug in, write the general formula first. When you're good at this, when you're feeling you have mastery, then you can skip some steps. But when you're first learning, write the general formula and then plug in. Well, I think you can probably do this in your head, but for the practice, you might want to try to do it in one step on your calculator, because in your homework problems, you'll probably have calculations you can't do in your head. You can do this in one step on your calculator. 1 squared plus 3 squared. Calculator will give you 10. Well, we still need to get this hypotenuse term by itself, because it's still squared. Well, the opposite of squaring is square rooting. So we have to take the square root of both sides. When we take the square root of the left-hand side, that leaves the hypotenuse term by itself. That gets rid of the square. But because of the golden rule of algebra, if we've taken the square root of the left-hand side, we are obligated to take the square root of the right-hand side. Otherwise, things are not going to work. Now we can use our calculator to find the square root of 10. In some circumstances, you might just say the answer is square root of 10. That might be good enough. Maybe we could just say that the hypotenuse is root 10. That might be okay. But in some problems, it's better to give your answer as a decimal. So as a decimal, this would be 3.2. Always good to build your new information into the sketch. Now we have to try to find this angle. Well, let's give the angle a name. Let's call it theta. The convention is that we're going to try to figure out this angle using only in the information we were originally given. Well, the information we were originally given is marked with the asterisks, the 1 and the 3. So originally we were given the adjacent side and the opposite side. Which trig function could we use when we are referring to an adjacent side and an opposite side? TOA, tangent. It's the tangent that refers to the opposite and the adjacent. So let's take the tangent of theta. As usual, I'm going to write the general formula and then plug in. What do I plug in for theta? Nothing. I don't know what theta is. What do I plug in for opposite? 3. What do we plug in for the adjacent side? 1. We probably don't need our calculator for this. The tangent of theta here is 3. But we still haven't accomplished our goal. Our goal is to get theta by itself. So we got to get rid of this tangent function. The way to get rid of things is by doing the opposite. What's the opposite of tangent? Well, the mathematicians have invented something called inverse tangent, which they say is the opposite of tangent. So the way to get rid of a tangent is to take the inverse tangent. And because of the golden rule of algebra, we have to take the inverse tangent of both sides. What happens when we take the inverse tangent of the left-hand side? When you take the inverse tangent of the left-hand side, that accomplishes our goal and gets rid of the tangent. So we're just left with theta. But then we have to take the inverse tangent of the right-hand side. So here we're taking the inverse tangent of the right-hand side. Okay, so hopefully now you're comfortable with finding inverse tangents on your calculator. The inverse tangent of 3 is approximately 72 degrees. So this angle is 72 degrees. By the way, remember that anytime you're using trig functions, you have to make sure that your calculator is in the right mode. Usually, we're going to be working with degrees, so you want to make sure your calculator is in degree mode. If your calculator has not been giving you the right answers, maybe it's because you're in radians mode. So make sure that you're in degrees mode. On a TI 83 or 84 calculator, you can just hit the mode button to check whether you're in degrees or radians mode. So for these problems, we want to be in degrees mode. We're focusing on solving problems in degrees. If your calculator has been giving you the same answers that I've been getting, then you must be in degrees mode. But if your calculator has not been giving you the right answers, maybe it's because you're in radians mode and you need to shift to degrees mode. So that's something you want to remember for the future. Anytime you're doing trigonometry, make sure you're in the right mode. It's possible that some of you never change your mode. If you never change your mode, then you'll always be in the correct mode. But eventually you may come to a point where sometimes you want to use degrees and sometimes you want to use radians. Well, if you've ever gotten to the point where you're shifting back and forth between degrees and radians, then it's very easy to accidentally be in the wrong mode. So you have to get in the habit of checking for that. But again, if you never change your mode, then hopefully you'll always stay in the mode that you want to be. For most problems, we're going to do degrees.